Hello friends, welcome to Susan and John Matthew. This is lesson number 4 in NEB Grade 12 Mathematics exam preparation. And in this lesson, we are going to learn implicit differentiation. And this is the last lesson in revision. And from lesson number 5 onwards, we will learn the important topics for grade 12. I hope you're like really good with product rule, quotient rule, and especially chain rule. And now let's start with implicit differentiation. Till now, when you learn product rule, quotient rule, chain rule, all the functions used to look something like x square multiplied by log x, or maybe y equal to root under sine e to the power x plus x square, etc. etc. These are classified as explicit function. What do you call them? Explicit, because one variable is clearly given as a function in another variable. That is why they write y is equal to f of x. But implicit is a relation. So we will generally write this as f of x comma y equal to k, because in grade 12 you always deal with only two variables. So we write f of x comma y is equal to k. For example, if the cost of a function depends on the labor and time, then this function depends on two variables. And if I write like this, it means the cost function depends on L and T, and the constant is written on the right side, that is 5. Okay, anyway, I'll give you more examples. X cube plus y cube equal to 25. So clearly this is an implicit relation. So basically implicit functions are relations, implicit relation in which all the variables will be connected by plus, minus, product, etc. etc. Anyway, differentiating this stuff is super easy. So write one question. If x cube plus y cube equal to 25, find dy by dx. Now look at this. When you see dy by dx, you have to understand you're differentiating with respect to x. That means you're comparing with respect to x. So you have to start like this, differentiating both sides with respect to x. So what should you write first? We have to write differentiating both sides with respect to x. Now look at this. What is the derivative of x cube with respect to x? X cube with respect to x will be 3x square. So I'm just writing the formula x power n, nx power n minus 1. Plus, now I have to differentiate y cube with respect to x. Now wait for 2-3 minutes. We have to understand this properly. Maybe you know the answer because you already learned this stuff in grade 11. Okay, so y cube is a function which has a domain variable different from what we differentiate. So all you have to do is you have to write the derivative and multiply by dy by dx. Now if you want to understand the logic, very simple, it is our chain rule. Can you tell me what is the derivative of something to the power 3? According to chain rule, it is 3 into same thing squared multiplied by derivative of that something. So can you see something to the power 3? So it became 3 into y square multiplied by what is the derivative of y with respect to x? That is our dy by dx. Anyway, I'll write this 3y square into dy by dx, and obviously the right side becomes 0 because 25 is a constant and the derivative of a constant is 0. Now this is basic algebra. You have to find dy by dx. That means you keep the stuff with dy by dx on the left and take everything else to the right, or subtracting 3x square on both sides and dividing both sides by 3y square, dy by dx equal to minus x square by y square. Let's try one more problem. Please write question number 2. If sin x plus sin y is equal to x square plus y square, find dy by dx. Okay, now look at this. A very clear case of implicit function. How do you recognize implicit functions or relations? They are, um, to be 100% mathematical, these are not functions, because function means for every input there should be only one output. So we should call them implicit relation, but in a casual way to learn, I'm calling it function. Okay, so how do you recognize this implicit so-called function? So all the variables are mixed up. So I had to write differentiating both sides with respect to x. What's the derivative of sine x with respect to x? Now some of you might ask me, why did I not apply chain rule here? Okay, we can apply. Come on. What is the derivative of sine something? Cos the same thing. Multiplied by what is the derivative of something with respect to something? Let's say dx by dx. And that is why we never write um, this stuff when we differentiate with respect to same variable. So cos x plus, come on, now we have to differentiate sine something with respect to x. So cos y into dy by dx. Now I'm sure in grade 11 itself you learned the shortcut. Whenever you have a function in y, your teachers would have suggested put dy by dx. That's it. Is equal to, what's the derivative of x square with respect to x? 2x plus y square with respect to x. Warning, you're differentiating something square with respect to x. So 2y multiplied by derivative of something with respect to x. Now one more step. And what's that step? Collect dy by dx on the left. So cos y dy by dx minus 2y dy by dx is equal to 2x minus cos x. Then take dy by dx common. So if I take dy by dx common, I'll get cos y minus 2y is equal to 2x minus cos x. So dy by dx equal to 2x minus cos x, the whole divided by cos y minus 2x. Let's work out one more problem and end this video, and that is differentiate x cube plus x square into y square plus y cube equal to a cube. Okay, clearly implicit. So I had to find dy by dx. So I'm going to write differentiating with respect to x. So 3x square plus, now look at this. X is a variable, y is a variable. So we have to apply product rule. So I'm going to apply product rule. So I'll write one of the function. I told you long back, the rule is so simple. Write one of them, differentiate other. Plus, write the other, differentiate the first. Okay, so I'm going to write x square. That means I have to differentiate y square. Warning, it's not 2y. 2y dy by dx. Plus y square multiplied by, I have to differentiate x square. That is 2x plus y cube with respect to x. Can you see it's an alien variable? You're differentiating something cube. So 3y square dy by dx is equal to 0. Why did I write 0? Constant. Now what's the next step? I have to collect dy by dx on the left. I will allow only terms with dy by dx on the left. So I'll keep these two on the left. Take the other quantities to the right. 2xy square. You can take common and simplify. I'm not simplifying much. So take dy by dx common, etc, etc. Comment below whether you got this answer. I'll be back with the next video. And our next video is like very important for everyone. That is derivatives of hyperbolic function. So I'll be back very soon. So till then, my friends, bye.